You ever feel like you need a helper in the shop? Well, that's what this DVD is all about. These are great shop tips that I'm bringing you today. There's a lot of information coming at you here. How to get banding on plywood with a V-cut and a very delicate look on that banding when you're done. You're going to swear it's one big board. How to muffle the sound from your air compressor. How to reduce vibration on big tools in your shop. Add a little light to your work area. We've also got a hand tool expert. Adam Peterson is going to come in. He's going to talk about hand planes, sharpening, all sorts of different things to get your hand tool work a couple of steps ahead too. So lots of great information coming at you here that's going to make your work in the shop a lot easier. You're going to feel like you got a little elf helping you every step of the way. Let's get started on this stuff. Here's a problem I have run into in my shop more than once. I've got a part like this 3/4 inch thick case side, and I want to put this edge banding on it. So I'm going to get my glue and apply glue and film the glue out, and then I want this to go on here. And meanwhile, this piece is rocking and rolling all over the bench. So I want a way that I can stabilize this and make sure that once I'm working on it, it can't tip over. I've got a shop-made solution for this. These are pretty cool, very easy to make. I've got a notch cut in here. The notch is going to capture my material. Get one of those on each end. And with those on there, this piece is very, very solid on my bench. Now, if you think that's great, that's not all. Because if you order today, here's the deal with these. I'm going to show you how to make these things up. When they're done, they're going to be perfectly square. Edges parallel, ends perpendicular to the edges. So in addition to what we're doing here, I'm going to show you another application in just a sec where you can use them for assembly blocks. You're going to find all sorts of applications for these. So first, let me show you as an assembly block how this is going to help you out. Then we'll get started on the process of what you need to do in order to make up a set of these. I've got a cabinet I'm assembling here, and of course, with any kind of assembly, you generally want to make sure everything goes together square. So 2 of my assembly blocks are down underneath here. That'll keep everything up off the bench. You're going to see the value of that in just a second. Now, before I put anything else together, I want to make sure that the rail I have in here so far is nice and square, and it's going to stay put. So I'm going to take one of my assembly blocks and do this. Now, remember, I told you we're going to make these things perfectly perpendicular. So when I do this, and then this, what I know now is that that rail is absolutely dead square to the case side. The box is only 5 by 10, so a 6-inch clamp would grab it this way, and a 12-inch clamp will grab it this way, clamps that most people typically have around. When I go to put the bottom in this cabinet, I'm going to start by taking another assembly block, getting it right on the dado that I have down here, even with the edge, and I'm going to clamp it. Then, when I'm ready to put the bottom in, it kind of gives me a guide. I can run right down my assembly block, drop that right into the dado, and then, of course, once I clamp it in this direction, this is perfectly square. So what's cool about this is that the blocks are going to act as supports so that everything stays put and is dead square, so that nothing tumbles out of place when I go to put the last case side on top. So in addition to the notch, which will hold stuff vertically for you, if you're real careful about the cutting, and I'll show you how to do that, you get these babies perfectly square, and they're going to act like an extra pair of hands when you're putting parts together in the shop. Here's what the boxes look like done. Here's what they look like as they go together. So not a lot of parts here, 6 parts per box, 2 ends, 2 sides. I stuck with 1/2-inch material for everything. Keeps them nice and light, but it's plenty rigid. It's 1/2-inch plywood. It's just BC stuff from a home center. Now, the ends I made 1/2 by 1.5 by 5. The sides then are 1/2 by 1.5 by 9, because the faces are 1/2 by 5 by 10. When you put this together, glue only. Don't put any mechanical fasteners in here, because you'll see in the next step we're going to do a bunch of cutting at the table saw. So we don't want to take a chance of hitting any staples or brads. So step 1, glue it this way. Don't worry too much about squaring this assembly up, because in the next step, you're going to take that and clamp the faces to it. And when you put the faces on, those should be cut nice and squarely, so that as you put them onto the frame, you can pull the frame into alignment and get that just right. It does take a lot of clamps. because we want to make sure that the faces close against the frame all the way throughout the assembly. So get that clamped up, give that a chance to dry. Once that's dry, our next stop is going to be at the table saw. No matter how careful you are over at the assembly bench, when these come together, they're going to be just a little bit kerflooey. So my face is sticking past that edge just a little bit, past that edge just a little bit. That's okay. We're going to fix that right now. So what I'm going to do is I've got my saw unplugged, and I'm going to bring the fence over, sliding my block to the blade, and just doing this, what I'm looking at is how much material I'm about to skin off. What I want to do is get to a point where if there's a shoulder, like this one has right there, I want all of that to come off. Now the material's a 1/2 inch thick. You don't have to leave too much behind. So we could easily take off an 1/8 inch on this. We don't need to take that much off in this case. But that's why there's some excess to work with, and it's why we don't have metal fasteners in here, so we don't have to worry about hitting anything. So I am in pretty good shape right there to do this edge. Then I'm going to flip it edge for edge, put that new fresh edge against the fence, move the fence over just a little bit, skin the other edge. That's going to give us 2 perfectly parallel edges. So I got to get my saw plug back in. We'll be ready for cut number 1. So far, so good. We've got 2 perfectly straight edges now. They're nice and clean. Most importantly, they're absolutely parallel to each other. Blade selection is important. I'm using a good plywood blade for this so that I get a nice clean cut right off of the saw blade. Next thing I want to do is cross cut the ends. So I'm going to unplug my saw again so I can do that visual alignment like I did before. This time, though, I'll be using a miter gauge. So second verse, kind of same as the first here. What I'm doing is saw's unplugged. I'm eyeballing this so that I'm just going to skin that end. Now I can plug in the saw, make the cut. What I've also already done is set up my flip stop so that after cut number 1, I can put the stop down, butt against the stop, and that's going to move me over just a little bit, skin the other end, and then we should be all set. It's imperative that this isn't worth doing if your miter gauge isn't perfectly square. So it's imperative that you take the time to check your miter gauge. These cuts have to be perpendicular or the assembly block is really no good to you. So saw plug back in, and I'll be ready to make a cut here. Now we've got a box perfectly square, and look, you can tell by the cut what the squaring cut did for us. Obviously the end wasn't laying there perfectly square because I took a lot more off of this corner than I did off of this corner. So that's the benefit of doing the cut after assembly. Next thing, I'm going to get a dado head on here, and we'll have a look at getting that notch cut this way so that it works as a device to hold your pieces upright on the bench. Here's where I'm at now. I've got 3/4 of an inch worth of dado in the table saw, and it's set 1.5 inches high. Now, neither of those numbers are real critical. It's going to depend on what you plan on using the boxes for. Most of the assembly I do is with 3/4 inch material, so 90% of my assembly boxes have 3/4 inch notches cut in them. A couple have half, a couple have quarter, because sometimes I run into those applications as well. What you don't want to do is cut more than 1 notch in one box. The reason for that is that when you start using this as a squaring device, if this thing is willy-nilly with notches, it's going to weaken that, and you're not going to get a good squaring effect out of it. So 1 notch per box. The 1.5 inch height is helpful, but if you only had it at 1 inch, you'd still be okay. What I want to do is pass this on edge over the blade. I've got this set up so that using my flip stop, I am about centered on the box. Same thing there. If you miss that centering just a little bit, don't sweat it. It's not a big deal. But having it close to the middle is going to give you the most outrigger type support when a piece is vertical in here and you're relying on this thing to prevent that piece from tipping. That takes care of us here at the table saw. The remaining steps, pretty easy to do. you look at the finished box, I've taken the corners off. I did that just with some sanding. And the reason for that is that when we use this as an assembly block and we tuck it tight into an inside corner, it's going to work better if this has been relieved. In other words, we don't want to ask this outside corner to go right into the inside corner on something like a cabinet carcass. So just a little bit of sanding is going to take that off. Then, this is also darker looking than this because it's got a coat of finish on it. We're going to use these in the assemblies where there's glue dripping out, and if you're not careful, you'll end up gluing your assembly block right into the cabinet carcass. So put a little bit of finish on these so that the glue can't stick to them. You'll be all set. So make a few of these. In fact, once you're making them, make a bunch of them, because once you start using them, you're really going to like them. You're going to keep finding more and more applications for them. They've really added a lot of ease of assembly to my shop, and I think they're going to do the same for you. Here's a trick that's going to let you cut any angle that you need right here on the table saw. For instance, on this carcass, what I need to do is get this really steep angle cut off the top end here. Impossible to do with a miter gauge, pretty darn tough to do with a taper guide. So I've got a different approach for this. Here's what I'm going to do. I'm going to end up with this piece of scrap adjacent to my cut line, fasten that in place. This will ride on the fence, allow me to perfectly cut that angle. Now here's the key to this. I'm going to nail this down. So I'm nailing it into the waist side of the line. This is the part of the carcass I'm keeping. So I have to position this board, the width of the blade, away from my cut. So what I did is I took a piece of scrap, cut into it partially, shut off the saw, took it back out. That shows me exactly how wide my saw blade is. The way I'm going to use that is I'm going to put one side of that kerf on my layout line, and then I'm going to mark the other side. And I'm going to do the same thing over here. So now I've defined the width of my saw kerf, and that's going to show me exactly where to position this piece of scrap wood. Still moves from the bench, so that's good. We didn't nail it down. Now here on the saw, with the saw unplugged, what I need to do is position this so that my saw blade is going to come right down my left side of this piece of plywood, the plywood on the waist side. Just like that. And we're good to go. So I plug my saw back in, and I'll be ready to make this cut. Very easy approach. Get a nice straight cut. Really, really good way to get any angle you need cut on any piece of wood you have. You can't beat a scroll saw for doing tight and intricate turns when you're cutting into a piece of wood. But as well as they work, we can help them just a little bit, especially in a case where you're using a blade that's maybe just a little bit too wide for the tiny radius that you're trying to turn. It's pretty easy to help the blade out by rounding the back corners. First, let me give you an example of what I'm talking about here. I've got kind of a scroll saw blade on steroids here. Imagine that this piece of wood is a scroll saw blade, and that the lines I've drawn here are the path that the blade is trying to make through the material. So as I cut a turn, of course the teeth are here on the front. When the back corners are square, that square corner is always dragging across this part of the curve. So as a result, we have friction there. It's possible that that corner is also kind of messing up the quality of the cut that we're getting on the curve back there. So if we can eliminate that corner, it's going to make it easier to turn, and possibly we're going to get a better surface quality inside the cut. It's very, very simple to do. This is a whetstone. In this case, it's a diamond stone, but that's not imperative. You can really use any whetstone. You can even use a piece of emery paper wrapped around a board. All I'm going to do is run the saw, and while the saw is running, I'm just going to ease that back and forth over that back corner. Really, just a few seconds of this is all it takes. And what that's done is ease those back corners. It's going to make a good tool work even better. If you're looking for a real easy and straightforward way to get cabinets hung on the wall, I've got an answer for you. It's called a French cleat. Some people call it a Z-strip. And the way it works is that take one piece, rip it at a 45-degree angle, and that goes into your cabinet just like that. Then you're going to take another piece, also cut at 45 degrees, and that's going to get mounted to the wall. The way it works then is that when we take that cabinet, hang it on the wall, and let it come down to a rest on top of the piece that's already fastened to the wall, they engage, they lock together. Now, the way to do this is that the piece that's on the wall, you'd like that to be a little bit shorter than the piece that's in the cabinet. So once the cabinet is hung on there, you have room to do a little bit of lateral adjustment. The third piece I've got sitting here is a piece that would go into the bottom. That does not need to be cut at a 45-degree angle. What's going to happen once this is all in place, you've got the cabinet hanging on this Z-strip. I've got the other cleat in the bottom. Then I'm going to run screws through those components to hold everything tight to the wall. So this cleat is all about making it easy to get the cabinet on the wall. You're still going to secure it once it's up there. Now, this made things so easy for me that the cabinet I have over here is a great example of why you would do this. I've got a 12-foot run of cabinets here made out of MDF. I built them in 3 4-foot sections. So here I was ready to hang all these cabinets on the wall by myself. And what I did is I got the Z-strip up on the wall, the mating component on the back of the cabinet. So I was able to pick this up, kind of slide it up the wall, get it over the Z-strip, and then let it drop on top of the cleat that's on the wall. If you do a good job putting the cleat on the wall, meaning you get it nice and level, when the cabinet hangs on it, the cabinet should also be level. So because there are 3 cabinets in a row here, what I did is I got the end one on, right where I wanted it, secured it in place. Put the cleat up on the wall so it was just a little bit short, hung the cabinet on it, slid it over, then fastened cabinet number 2 to cabinet number 1. Here on this one, this was the last one, got the cleat on the wall, hooked the cabinet on it, slid it over, secured number 3 to number 2. So this French cleat concept is a really, really good and simple way for you to get cabinets up on the wall, even when you're working by yourself.
Now I've got a chisel here, and it's had a little bit of abuse. There's a nick right up there in the leading edge of the chisel, and I'm going to show you a way to hone that out. If I were to take this chisel right to my whetstone, I would have to hone it for 3 months and 2 days and 7 hours to get that nick out. A faster way to do that would be to take it to a grinding wheel and grind that nick out. And by doing that, we're creating something called a hollow grind, and I'm going to go through that with you right now. So, the hollow grind is created by the wheel, and that creates a concave surface on the bevel of the chisel. So the way we would tell the angle is by using the 2 points. You have this leading edge and the heel, and if you created a straight plane across those 2, you'd want to create a 25-degree bevel or thereabouts, depending on which you like to bevel your chisels at. This is really helpful when freehand grinding or honing on a whetstone because it creates 2 points of contact on your stone, and it really gives you a nice solid register on your stone. So let's go through how to hollow grind on a grinder. Now the way we get set up to hollow grind is unplug the grinder, lay your chisel flat on the rest, and you're going to just lean over and visually check to see that the wheel's high point is kissing the very center of the bevel. Now for a beginner or anybody really, you can take a black permanent marker and color your bevel. Just color it in. And this is going to let you see really easily progress. Because the next thing we're going to do is plug the machine in and just kiss this chisel to the wheel, turn it over and see if we're hitting it right in the middle. Masks are always a good idea too when using a grinding wheel. So, here we go. I'm just going to take a really light kiss. We're not jamming that chisel in there. We're just really lightly going in. That's it. Now what I've got there, you can see that just right in the center there, I took some black out, which means that the angle or the bevel of this chisel is going to be the same if I keep grinding at that angle. And that's what I want. So I'm going to go back to the wheel, and again, just very slow, light kisses on the wheel. We're not going to try to hog a whole lot of meat off of this thing in one go. One thing we're trying to avoid is heating this chisel up. Steel changes its temper at a pretty low temperature. So if you're dipping it in water and it's going, it's too hot. If you can't have your hand on the chisel, it's too hot. You got to keep the steel cool or you're going to change the temper and ruin the chisel. So just nice light passes. And I'm going to move the chisel back and forth just a little bit. I don't know if you can see this, but there's just very light sparks coming off that wheel. Check to make sure you're not overheating it. You can see again I've made quite a bit of progress just from that really light kiss, and I haven't made it out to the leading edge, and that's really where problems with heat start to occur. Progress. I've got just a little bit there, and I'm feeling that it's getting a little warm, so I'm going to cool it off a little bit. Just wait a second. I never use water on my chisels because I don't want to let my chisels get that hot. An alternative to that would be to hold the tool steel down to the cooler part of the machine, and that'll help suck some of the heat out. But again, I can still have my hand on there. It's just warm. It's not hot. And I'm ready to go again. Just have patience with this, and you're going to have better results. Cooler off. One thing you're looking for is that there's a nice, consistent spark pattern across the whole length of the chisel on the wheel. That means your wheel is really nice and true. You don't want to have a really high spot in your wheel that's just grinding a narrow part of the chisel. This is especially true with plane irons. Not so important with chisels, but look to see that you're getting a good spark pattern. I'm ready to go. It's cool again. I'm just going in and out. I'm not just bringing it back, kissing it up there. All right, I know I'm hitting the leading edge now because I can see sparks flinging over the edge of the chisel. And so what I can do now is start to see that I'm keeping the chisel square. So just take a basic square and check to see that you're square across. And if you're not, I'm high on this side, so I'm going to take that back to the grinder and just try to take more material off this side than I do on the other side. It's just a trial and error sort of thing. I'm going to let the chisel cool down, check it once again. All right, I'm pretty square right across. So just one last kiss there. That looks pretty good. I've got a nice, consistent grind all the way through. I don't know if you can see that or not, but it's just a nice loop right through. I'm going to check it for square and make sure that that blade's nice and flat across, which I am. And now I know that I'm ready to go to my Waterstones to hone that to a nice polished finish.
I'm working on a stool that I'm building here, and I'm putting everything together with screw pockets and glue, like I've got here. So all of the assembly is going to be done with those screw pockets, and you might notice that the screw pockets are on the side of the project that shows. These are going to be used to fasten the top a little bit later. The reason I put them on the outside and let them show is two things. One, especially here on these inside rails, it's a lot easier to run the screw in there from the outside face than from the inside face. And I'm going to take advantage of this joinery and make it into an accent. So it's a little bit unusual. Typically, you put screw pockets where they can't be seen. In this case, I want them to be seen. This is the top I'm working on here. I had to glue two pieces together in order for it to be wide enough to make the top. So what I did is I jointed the edges, I brought them together, and then instead of clamping, I used screw pockets to draw those two different pieces nice and tight. I want the screw pockets to show, so when I drilled them, that part's the same as what you'd always do with screw pockets. Drilling the holes isn't any different. But because they're going to show, you do want to be careful about your layout and have some kind of symmetry or uniformity to it so that they're going to look okay when you're done. You don't want them randomly located. What you want to do is check the size of the drill for your screw pocket jig. A lot of times they're about 3/8 of an inch. Whatever size that bit is, that's what size dowel we need. So step one, I'm going to clean out that hole a little bit. Slip the dowel in there. And then using a pencil, I'm going to strike this off like this. And that's going to give me a line on which I can cut this. Now, it's not imperative, but it just is going to save you some dowel. If I cut this angle now, then I can use the other end of this for another screw pocket. If I leave it standing real strong, I'm wasting more 3/8 inch dowel. So I'm going to cut this off, then we'll come back and we'll glue that in and then have a look at finishing off the accent dowels that are in these other holes. With that dowel trimmed, I'm going to put just a little bit of glue in the bottom of the screw pocket. And then I find it's helpful if I use a nail set, I can tap that in so that I know it's seated all the way down. There we can see some glue coming out, so we know it's getting all the way in there. Next thing, because of the way I cut that, they're standing just a little bit proud of the face. So I'm going to clamp my work down. And then using a real fine cutting pull saw, I'm going to cut this off nice and flush. Once that end one dries, I'll do the same there. Then I'll spend a little bit of time with the sander cleaning this up. Then you can have a look at just what this looks like as a finished product. Well, these are looking good. You can get an idea of, now that they're flush cut and I've done a little bit of sanding on them, what kind of an accent they're going to add to the top of this board. It's real cool to do this with some contrasting wood And you can get dowels, of course, in all sorts of different flavors, so you'll be able to find one that contrasts nicely against the project you're doing. So this is a great way to take advantage of screw pockets for their joinery ability, and instead of hiding them inside the project, let them show and turn them into an accent. I know plenty of woodworkers who just don't have enough vices, and that is vices with an S, not vices with a C, because a lot of us have too many of the other vices. So this bench is an example. It's a great bench, but I don't have a vice on it. I'd like to hand cut these dovetails, so I need a way to hold this in place. And actually a hand screw clamp is a great way to do this. You'll be amazed at just how well this works. First, let's look at the hand screw clamp itself, because sometimes getting stuff into these clamps is just a little difficult to do. When I turn this, and the jaws open and close, they don't always travel parallel to each other. So if I've got one handle slightly more advanced, suddenly I've got two jaws that don't line up. If they're in that pattern, if they're in that configuration, and I try to grab a chunk of something in there, what happens is that it's gripping the material here, it's not gripping it there, and I really don't have much of a bite on it. So the first step is you got to understand the right way to use a hand screw clamp. So I'm going to get the jaws just visually close to parallel. They don't have to be perfect. Then I'm going to take my stock and put it in the butt end of the clamp down here and close it until it pinches. Got to be open just enough that I can get that out of there. Now where I really want to grip my material is in this end of the clamp. So I'm going to put it in there and close this. So what just happened there is that I set this distance perfectly to the thickness of that stuff by squeezing it in there. Then, when I put it in here and close the jaws, they're dead parallel to the face of this piece and to each other. So now I have a really good grip on that material, and it's not going to budge out of that. Now here's the vice part of this whole deal. I'm going to take that hand screw clamp, and with a second clamp, fasten it down to the bench. So now I've got a work surface here that I can hand cut my dovetails, I could do a little bit of chopping, whatever I need to do, and I don't have to worry about adding a bench vise to my bench. So hand screw clamp combined with another clamp is a great way to secure material to any bench that doesn't have a vise. You know that standard HVAC stuff from a home center, heating, ventilating, air conditioning, can be used for dust collection in your shop. But before we go too much further, check into a couple things. A lot of this is 24 gauge sheet metal. Make sure that if you're going to go down this route, that your dust collector doesn't pull so much that it's going to collapse the metal. You should be able to get those kind of specs from the dust collector manufacturer. What I want to talk to you about is taking a turn for the better or taking a turn for the worse. What happens is that we have a straight run and we're going to drop to get to a tool. So you need a 90-degree turn. It's really, really critical. In fact, it's imperative that in dust collection, in order for the stuff to keep moving, we have to have these turns the right radius. As a general rule, you want the radius of your dust collection turn to be about 2 times the diameter of the pipe. So 4-inch pipe, like I've got here, 8-inch radius. Now, when we look at this, there's no way that that thing has got an 8-inch radius, but I can still use this, and the answer is I need 2 of them. So first thing I'm going to do to make this fly is I'm going to get 2 of them put together, and then I just got to remanipulate everything. So what I want to do is spin, spin, spin here until I get one big elbow out of 2 small ones. All right, it takes a little bit of playing with all the different segments here in order to get that corner to form. But what this will do by using 2 of these together, it gives us a much more sweeping radius, a much bigger radius. And the deal is that on a single correctly formed 4-inch pipe turn, 4-inch 90-degree turn like this, that's the equivalent of 6 feet of straight pipe. That's how much turbulence we're creating. So remember that every bit of pipe you add to your system reduces the effectiveness at the end of that pipe. So if you have an incorrectly formed 90 degree, it's going to be even greater than that 6-foot radius. So now that I have this where I want it, the next step is get a couple sheet metal screws in there to hold the 2 individual elbows together. Just sheet metal screws alone are going to be fine on your furnace, but they're not fine on dust collection. We want to have no leaks. We want to have everything nice and tight. So what I want to do next is caulk this. Now here's the problem. A lot of this stuff, when it's brand new, has got kind of a greasy film on it, and you want to get that off of there because otherwise the caulk won't stick. So what I did is I took the parts right here where they're going to come together, and with a little bit of vinegar on this paper towel, I wiped those parts off to get that schmutz off of there. Once it's done, once that's nice and clean, then just a nice small tip on your caulk gun, and this is 100% silicone caulk. All the way around the seam. I'm going to come back and kind of push that down and in, make sure it's worked right down in there between the two pipes. And part of what that does is put excess caulk on my finger, which is okay because I got a spot for it and it's not on my pants. I'm going to go here over the screw heads because what those screws just did is put a hole in my system. Now, give that caulk a chance to dry before you work with this. And this is a very effective way to get the correct radius of 90-degree turn out of a couple pieces that were the incorrect radius to start with. Hand tool woodworking is all about practice, I can't say that enough, and about accuracy. When I've taught people to hand cut dovetails, one of the things I've seen if they come into a class with bad habits is that they'll try to cut the entire joint from one face of the board. So what happens here is that on this board, I've got a layout coming down this side. I've also got a layout coming down this side. How can I follow that line when I can only look at this face of the board at one time? Because I don't have any eyeballs back there. So here's what I'm going to do. From this face, I'm going to cut until the saw touches that corner and the baseline down here. Then we'll stop and we'll go on and figure out what we're going to do about that line on the other side. Got to know when to stop because you definitely don't want an overcut to project past your baseline right there. So I'm complete from there to there. Inside there it looks like an angle. Now I'm going to spin that around. Now I can see the line from the back side. I'm going to do the same thing. What's cool is that this side is easier because I've already got a kerf in place there to follow. So at this point, I'm really kind of letting the saw just float in my hand. I'm not steering anywhere near as much. Following the line down this face, following the kerf across the end grain. And again, big deal, make sure that you don't go past that baseline down there. I'm going to take points off for that if you do. Now, think about what's inside there. I did a cut from this side coming up. I did a cut from this side coming up. So we're not done yet. We've got kind of an upside-down V going in there. So now, level the saw out. See, it can only go into the kerf so far because there's a hill inside there. So now, I'm barely holding the saw at all because all I want this blade to do is follow the existing kerf, a little bit of down pressure. I'm going to watch the baseline there. Now, in this case, I am going to peek around the back. Watch the baseline back there. Right there, I'm done. So the key to this is just understanding that if you can only see two lines, you can only cut two lines. So I'm going to get those two, flip around, work from the other side, finish it by going straight down. A trick like that, a technique like that, is going to really increase your accuracy when you're cutting dovetails like I'm doing here. Air compressors are really handy in the shop. You can use them for brad nailers, pin nailers, staplers, blowing dust off your project, but they're really, really, really loud. They're really, really, really loud. So I'm going to show you how you can muffle the volume of sound that's coming off of this air compressor so it's a little bit more quiet and a little bit more pleasant to have around you in the workshop. It's a very simple deal. Box your air compressor. So what I've done here is I've used 3/4-inch BC plywood, very inexpensive from a home center, and I built a box that completely surrounds the compressor. And a couple things you've got to do here. You've got to get some ventilation holes because air compressors do generate heat as they run. So I've got 2.5-inch holes here at the top, 2 at the bottom. I did the same thing on both ends. Part of what I'm looking for here, holes on the top and bottom are important. Remember that heat rises. So as we get hot air evacuating automatically out the top, we'll have cooler air flowing in on the bottom. Everything is just simply glued and stapled together. Very, very simple joinery. It's important that you get enough glue on there. You're going to have a compressor vibrating inside this thing. We don't want to vibrate the box apart. So do a good job, good strong fasteners and glue, holding everything together. On this side of the box, we've got to let the air come out. So I calculated that whole location based on where my valve is on the inside of this, my coupler. So I got the hole punched in from the outside so that the air hose could thread in. Then on the very bottom of the box, I'll tip that up a little bit, I put some big corners down here on the bottom so that it just kind of spreads the load a little bit across the bottom of the box so I'm not stressing the corners so much when I move this around. So very, very simple idea, very simple construction. Just make sure that you, like I said, give the compressor the opportunity to ventilate. You're going to have to dimension the box, the muffler box for your compressor based on what you've got. So what I did is I measured the outside dimension of my air compressor. I added an inch, and that's the inside dimension of my box. So it provided a 1/2 inch of space on each side and up here at the top so that when that compressor is in there, it's easy to put in. I don't have to shoehorn it in, but it's not so large inside that as it vibrates, it's moving all over the inside of the box. Now, take this a step further. It doesn't take much to see that if I wanted to, I could put a hook out here on the outside of the box. I could have my air hose coiled up there, another couple hooks on the end, and I could have my nailers and my staplers hanging on there, maybe even casters on the bottom. So instead of lifting this up and trying to carry it around the shop, you'd be able to very easily roll it around the shop. Or if you ever have to use it inside a house, like to put in trim or something, it's going to make it that much easier to move there as well. So it's a great idea. It's a very simple idea, and it does a really nice job of making an air compressor a little bit more pleasant to be around.
Here I have a number 4 Stanley bench plane. It's a smoothing plane, and I'm going to show you a few things to help you tune up this plane to get really thin, paper-thin shavings from this plane. And it starts with the iron. So what we're going to do is we're going to begin by hollow grinding this iron straight across, and then we're going to introduce a very slight camber into this blade using our water stones. So let's go over to the bench grinder, and I'll show you how to grind that blade. So what I'm doing here is I'm going to start the right edge of the blade in the center of the wheel and just move the plane iron very consistently and evenly across the face of the wheel, trying to keep that plane blade square to the wheel. And you can tell that by how the sparks are coming off the blade. So I'll show you what that looks like. Go up, kiss the wheel, and just go right across. Really light stroke. And I'm seeing sparks happening all the way across the length of the blade as I go across the wheel. Just like that. One more kiss. That looks pretty good to me. So what we're going to do is take a square and check that up in a window or a light in your shop. And you want to have that blade relatively, the straight part of the blade relatively square to one side. It doesn't have to be perfect because you have a lateral adjustment on your plane. And you're also looking to see that it's straight across. And that is looking pretty good. So we're going to take that to our stones now. I'll start with a 1,000 grit stone that just came off a 100 grit wheel. And any wheel grit will work, but go for a 100 or an 80 grit wheel is usually good grinding. general grinding grit for hand tools. So let's go to the 1,000 grit stone, and we're just going to do a flat pass. And I'm rocking it between the hollow grind, the 2 points that are created by the hollow grind. All right, and what we're looking for there is that we've touched all the way across the front leading edge of that blade, and there's a nice 1,000 grit polish on there. And then we're going to flip over, go to a 4,000 grit stone, and this is where we start to create the camber on the 4,000 grit stone. What I'm going to do is I'm just going to polish that edge first, straight across, just like we did before, taking a few strokes. And then this is where the fun starts. You're going to put more pressure on the left side of the blade and drag down and across. And you'll do multiple strokes until you start to develop that camber. And then vice versa, you'll do the same thing on the right side. You're looking to put in no more than, it's minute the amount of camber you need to get the result you're looking for. So what a camber means is we're creating a convex shape on the end of this blade. It's very, very subtle, maybe a couple thousandths of an inch or thereabout. And a good way to tell if you're creating that is by looking at the bevel edge. You can see that there's this ellipse that's created right in the center of the blade, and that means I'm honing more on the edges than I am right in the middle, and that's what you're looking for. So it looks pretty good there. I can tell that I've hit that whole edge consistently with the 4,000 grit stone, so I'm going to move up to my 8,000 stone and do the same pass. I'll take a square pass with pressure all the way across, do a few of those, and then I'm going to switch it up, and I'm going to go left side, 3 or 4 passes, right side. And then for me, I just flatten the back on the 8,000 grit stone. And I'll do that one more time just to polish it up. Straight, left, right. Now that blade is ready to go. I'll show you what that looks like in the plane. All right, so I just have this nice, freshly honed, cambered smoothing plane blade. I'm going to put it together with the corresponding chip breaker. And the way I'm going to do that is just really gently slide that past, set it up like that, and I'm looking for the chip breaker to meet the edge of that plane blade with about a 64th of an inch or so of blade protruding past the chip breaker. And that's going to give you a really nice curl on your shaving, and it's going to help stiffen that blade right down to the very leading edge of that blade, and it will curl the shaving, which will help reduce tear out, which we'll get to in a second here. So now this whole assembly goes into your plane iron, and what we're looking for here is that your plane blade and the body of the plane create a very, very narrow gap here, and I'll show you what that looks like using a flashlight in 1 second. And you're looking for about a 64th or less. You're not taking off much shaving, so it shouldn't get caught in that very narrow throat. And that's going to help reduce tear out as well. So what that looks like is this. All right? So the way we get that is by changing the frog's position on the plane body. And there's 2 set screws right down here on the body of the plane once you take the blade out. What you'll do is you'll loosen those, and on the back of the plane here is another screw which you can twist counterclockwise or clockwise to move the frog forward and aft on the plane body. So you're going to push that forward until you get a really nice tight opening. And it's all trial and error. You have to put the blade in, take it out, check it. And you also want to make sure that that frog is sitting square to the opening or the plane sole. And that also just takes a little bit of trial and error and just feel it out. So I've already done that, so I'm going to show you what this looks like in action here. Snap that down, just like that. And just visually set your plane. use your thumb and drag across. If it feels heavier on one side, adjust your lateral adjustment. And that feels pretty good. So to get it set up to do your final cut, take a narrow piece of wood, stand it up, put it in a vise, or you can rest it on the tabletop just like this. So what we're looking for is to see if the depth of cut is consistent all the way across the blade. Now that's a nice shaving, but it's a little thick for what we're looking for. So I'm going to back the blade out a little bit and try it again. Okay, and I took it back too far, and that's okay. Just very gradually, that's perfect. Just whispers of shavings right there on the right side of the blade and on the left side. But you'll notice, because we put that camber in there, it's a little bit heavier right in the middle, and that's really what we're looking for in a smoothing plane. And what this does is it keeps us from getting plane tracks in the final product. So let's take that over to a flat piece of wood. It's a piece of cherry. Check to see that your grain orientation is right. And you may not get a shaving right away. You may have to lower that, but go right along the length of the board. I'm getting little bits of dust, which is probably from my planer leaving ridge marks. A little bit more. This is a great way to take snipe or scratch marks, or dings or dents out of your final piece rather than sanding them out. It's a little bit faster once you get the hang of it. There you go. It's a nice clean shaving. And as I start to flatten this, it's going to start to pick up more and more of a shaving. So this is what we're looking for, is really nice, thin, light shavings from your smoothing plane. And with a little bit of care on the grinding wheel and putting the proper camber in the blade, you can make great shavings with your smoothing plane.
The problem, anytime you use a handsaw, is getting that handsaw started in just the right spot. So we get our thumb on here and eyeball up against that pencil line and do everything we can to make the cut where we want it to go. However, there is a way to make this a little bit easier. What I'm going to do is start out by using a very, very sharp chisel. And I want the flat side of the chisel to the wood I'm keeping, the bevel side of the chisel, and the waste side of this dovetail socket. That flat side, or the point of the chisel, I'm going to put right on my pencil line and just a little bit of pressure straight in. So I'm still bracing with my thumb, but I've made just a little bit of a detent there. Now I'm going to flip the chisel over, come back this way, and what this will do is make a nice little V right here where the handsaw needs to start. What's nice about this now is that I've got a little downhill ramp going this way. So when I get my saw in here, it's going to bear right up against the shoulder that I created here. Remember that we came in straight in on this side. So when you come in with your saw and you get into that V cut, it's natural that the saw falls to the bottom of the V, ends up against that nice square face, and it makes it very, very easy to get the saw started in just the right spot. So it adds just a second or two to your work. I'd make that same V on each side. Remember, you're going to do left-handed and right-handed setups with the waste side and the keeper side of your work. So I'd make one of those Vs every place I'm going to start a handsaw. It's going to add a lot of accuracy to this kind of cut. There's a compressor inside this box. The box is to muffle the sound, of course. And when I run it, I can feel all the vibration from that compressor migrating right out through the floor. And this is not uncommon with tools that as they run, they have some amount of vibration. That's natural. What's bad is that on some tools, let's say a bandsaw that's got vibration, that vibration can make it very difficult to use the tool. Here you are trying to follow a line, and because the whole tool is jumping around, you can't possibly follow the line and cut correctly. So there's a pretty simple solution, a pretty easy way that you can take care of this. What we need to do is dampen the vibration. What we've got here is a hard surface, a plywood box, up against a hard surface, my floor, and as a result, there's no wiggle room here. Everything shakes. A really, really easy way to dampen vibration is to use hockey pucks. They're very, very dense rubber. They're easy to get. You either got to find a hockey family and get a bunch of used ones from them. That's what I did. Thanks, Mike. Or you go to a sports store and you just buy some. Once you've got them in hand, there's nothing in here but rubber. They're rubber all the way through. So as a result, they're real easy to work with. You can drill a hole right through it. Then you can run a screw or a bolt through that in order to fasten that to the bottom of the tool. Once you've got that in place, fasten it to the bottom. It's going to create a space in between, like a big washer, so that as this vibrates, this will continue to vibrate, but it's going to isolate that vibration from the floor, and it's going to do a good job of making the tool run better because you'll actually feel less vibration on the table of the tool, like that bandsaw I talked about. So check it out. Look for some hockey pucks. Add them to your tool, and you're going to find that this is a great way to ice the vibration that's happening on your tools in your shop. One of the things that a lot of woodworkers do is add an aftermarket miter gauge to their table saw to get increased accuracy. Now, on a lot of aftermarket miter gauges, there are devices like this one has that let me snug this up in the miter gauge slot. So the problem that we're up against is standard miter gauges often rattle around inside there. These miter gauges do not. What you'll learn from that sometimes is that when I snug the miter gauge in one spot and get it to be a nice fit, as I move through the miter gauge slot, it becomes a little bit tighter. Now the deal with that is that there might be slight variations in the width of the miter gauge slot itself. So that's what we want to discover here. The way to do that is take your aftermarket miter gauge, and I'm going to disable this snugger altogether. So that one's loose. The one in the back is loose. I'm only using the one in the front right now. We're going to use it like a feeler gauge. So right there, this is moving pretty nicely. As I move forward, right there, I'm starting to feel some resistance. I'm going to put down a piece of tape and mark that. So it started about there. And it's easing up. I got lucky with my tape there. It's easing up about there. So I'm continuing to check all the way to the back. Right there, it's kind of snugging up again. I'm going to actually run that all the way out to the end. It was pretty snug all the way to the end of the slot. The fix is really very simple. I'm going to just use emery paper. This is fine emery paper. It's 220 grit. Wrap that around a block, and I'm only going to work on one side of the slot. So as a result, the block is thinner than my miter gauge slot. I'm also going to hold it up off the bottom. Now, it wouldn't really hurt much if I skinned a little cast iron off the bottom, but you don't really need to. It's the side that we're concerned with. So if you do this, you're going to find it doesn't take much in order to get this to where it's just a perfect fit all the way down. But it's just experimental, and of course we can't put cast iron back on, so just take a few strokes and then try it again. That's about a gazillion times better already right there. A little more off the end. There it is, right there. So in real time, this is just a few minutes, not a lot of elbow grease at all, and there's no reason why you should ever have to do this again. So it's worth taking the time to do it so that when you use these snuggers, you can really optimize what they're capable of providing for you as far as a fit between the aftermarket miter gauge and the slot in your saw. A little bit of work with that emery paper, you'll have a perfect fit all the way throughout the length of that slot.
I've got a marking and a cutting gauge in front of me, and like most hand tools, right out of the box, they're not performing at their optimal level. So I'm going to show you a couple of quick things you can do to get a better cut out of both of these tools. I'll start with the cutting gauge. Right out of the box, pull your blade out of the housing, and if it does not have this shape here, a nice thumbnail shape, take it to your bench grinder and grind a rounded edge to it on a bevel. And the bevel can be pretty steep. It's not doing a whole lot of work, so it's not, a delicate edge is preferred to a really steep angle. And then take it to your water stones and just hone it really lightly back and forth across your stone. You can go up to 6,000 grit or whatever grit suits you best for that. It doesn't have to be super polished. It's not doing a whole lot of work. After you've done that, a lot of times you'll find that the brass in the rosewood or whatever wood, boxwood that your cutting gauge is made out of, is proud of the brass on the side. So just like a plain iron or anything else, you need to flatten that. So take some 220 grit sandpaper, stick it down to a flat surface, a table saw or a joiner, and smooth that or flatten that face out. And you're ready to rock and roll. You can put your tool back together and give it a test. Now for the marking gauge, unlike the cutting gauge, this tool has points. And right out of the box, those points are pretty blunt. And so what you can do is take a file and just hit the edges lightly and sharpen that point up. Just like that. And in recent years, those points have been made out of harder steel, so a Dremel tool works really well. You can take the aluminum oxide Dremel tool and just nick them on both sides to make a little bit finer point on your marking gauge. You can do the same on the back side if you have a mortise gauge. On that side, though, you'll need to be concerned about the height of the pins in relation to each other so that they cut the same depth with the same amount of pressure. So that takes a little bit more patience and maybe some trial and error in a piece of wood to make sure that you've got those pins at the right height. And a lot of times right out of the box, those pins aren't the same height, so you'll want to check that as well. And just like in the cutting gauge, flatten the face of this on 220 grit sandpaper, and you're ready to go.
I have got bad news for you, I'm afraid. If you're my age, your eyes are already failing on you. If you're younger than me, the bad news is they're going to fail on you. So where that affects us is that we get in the workshop and we have this finely detailed work to do, and there are a couple issues. One is making sure that there's enough light on your work so you can see what you're doing. The other is just plain seeing the work so you can see what you're doing. Two solutions in one product here. This is a magnifying light. So it's a very great addition to have to your shop. They're not that expensive. I've sourced one for you on the PDF and the DVD. So you can do things a couple different ways here. Commonly, there's a post that comes out the bottom of the light. Find out what diameter that post is. You can either drill a hole right into your workbench, or you can put a block on the bench, drill a hole in that, and then just clamp the block on. What's so nice about this is that when you have detailed stuff to do, like this dovetail I've got to cut in this board, I can secure this. And I've got now kind of my ambient light situation. Even though my shop is pretty well lit, when I turn this on, it makes a huge difference in the light here. And with the ability to articulate this and move it around and get it right where I want it, it makes it much easier to see where I have to make these finely detailed cuts. Now the other thing is that when I articulate this in just the right spot, I can look through that lens and magnify the cuts I need to make. And man, especially on something like a dovetail, this is almost scary big right now, and it makes it so much easier to see where I need to place that saw in order to get it accurately on the line. So it's all about adding light, adding magnification. Even though I'm wearing bifocals, this makes my job a lot easier to be accurate in my woodworking. I have stumbled across a smoke and cool and easy way that you can store stuff in your shop, in your house. If you're anything like me, once you see this, you're going to be all over this. Go into a cigar shop, right inside the door of the shop. They've got all of these cigar boxes piled up, and they're virtually giving them away. Not quite, but they're incredibly inexpensive. And what's cool about this is a couple things. You're recycling. You're taking these boxes from the cigar store, using them for other stuff. They're a very inexpensive way to add storage to your shop. And one of the things I really like is that if you look at the boxes, most of them are wooden. They're finger jointed. They're nicely made boxes. They're pretty robust. So for me, in the shop, I've ended up with a variety of applications, a variety of things that I store in these boxes, and the list just keeps getting bigger all the time. The boxes we're looking at here are wooden. There are also boxes like this that are paper lined. Some of these have cardboard cores inside of them. Some of them have wooden cores in them. So I know my kids like these more because they're a little bit more colorful. I prefer the wooden ones. So check it out. Call a cigar store in your area. See what they've got. This one was quite a find. My wife has been turning pens. And this one came already with the dividers in it because it was in there holding cigars. And it's the perfect way for her to display the pens that she's taken to a show to sell. So this is a really, really good thing to look for, a really cool way to add smoke and cool storage to your shop or your house. It's possible that in all the woodworking you do, there's nothing more important than getting a nice square piece of wood to start with. Because if that first piece of wood you start with is kerflooey, if it's not perfectly square in every direction, how are you going to make a nice project out of it? So this is all about squaring up stock. It's easy to do, but it's really important that you do this in the right sequence. Starting here at my table saw, what I'm looking for on this board is, does it have any rock to it? And it does have just a little bit. And does it have a concave, convex face? What I want when I go to my jointer over here in the next step is if I have a concave face, I want that to be down on the jointer. So I'm checking for that. And it's not really that this one has got a bow in it, making it concave or convex, but it does have a twist in it. So at this point, it doesn't matter too much which face I have down. Now, the other thing I want to look at is the edge of the board. And I'm looking there for a prevailing grain pattern. So on this one, when I look at the edge, I can see this stripe right here. And what we know about wood grain is that the analogy I always use is that it's just like hairs on a cat. And you need to pet a cat from the head toward the tail because that makes the hairs lay down and the cat likes that the best. Wood also wants to be petted in the correct direction. So when I run this through the joiner, this end should go first. Because the joiner head is then going to go this way, this way, this way. The fibers are like this, where I drew those lines. So as the joiner head comes by, the fibers are laying down. If we start in the other direction, if we start from this end, when the joiner head comes by, it makes the fiber stand up, which ends up looking like checks and chips of wood torn out of your piece when you're all done. So you want to make sure you get the feed direction correct. Now here at the joiner, a couple things on setup. I've got this set for a very light pass. It's at a 32nd of an inch. Going to make sure that I've got push pads ready. You don't want to lay your hands right on top of the material. I want pressure from this. Now remember at the table saw, I found that this had just a little bit of a rock to it. So what I want to do is find a spot. I'm going to do it here on the lead edge, and I'm going to hold that down. I have a little bit more pressure on my left hand than on my right. If I do this, if I start on my left and then I transfer to my right, what I'm going to do is make a nice smooth twist. We want the twist to go away. So I'm going to have a little bit more pressure from my left hand, feed this all the way through, start to finish, in one continuous pass. So now we can check and see where we're at so far. Looking for a couple things. When I flip this over, did the rough sawn go away? I've got just a little bit left on here. It could use another swipe. The other thing is, as it lays on my joiner bed, does it have any twist left in it? And it doesn't. So we got it nice and flat, but we don't have it as smooth as I want yet. So I'm going to do one more swipe on that face, and I think we'll be done. that passed, because the twist was gone, I was maintaining more uniform pressure between both hands. Isn't that a beautiful piece of quarter sawn oak? Now we're flat and it's smooth. I can feel that. So that's step one, one flat face. Now we're going to take advantage of that flat face and start working on edges. Again, what I'm looking for is, do I have an edge that's concave, which would be this one right here, and an edge that's convex, which would be this one. I want the concave side down. If I do convex down, then imagine this is a big, like a rocker or a banana. What can happen is that it feeds through and rocks, and I end up with a really smooth curve. What I want is a really smooth, straight edge. If I put the concave side down, probably what's going to happen is it'll touch on the lead edge, little will happen in the middle, it'll touch on the trailing edge. Just keep doing passes until I have a touch all the way down the length of the board. It's imperative now that that face that we flattened in the first step is the face that goes up against the fence. So what we're doing is we're making the bottom edge perfectly perpendicular to the face that's against the joiner fence. You can tell just by the sound there was no contact in the middle. A little bit more that time. As I let this rest on the outfeed table on my joiner and I look down its length, I can see that the edge I jointed is in full contact with the cast iron all the way down. The cast iron has been milled perfectly flat, so if it's meeting the wood all the way down, the wood must be perfectly straight. So now what we have is one good face and one good edge, a reference face and a reference edge. We're done at the jointer. Now we're ready to go to the table saw. Here's the deal. If all I do at the jointer is switch edges, I have a couple problems. One is, remember this edge is a little bit convex. So as I joint this, I'm not necessarily going to get it as straight as I want. The other issue is jointing this edge isn't going to make it parallel to this edge. So our goal out of this is to have all 6 surfaces parallel and perpendicular. So I have to come to the table saw for this. So now what I can do is set my table saw for the width that I'm trying to produce. And the magic of the table saw is that with that reference edge against the fence, my reference face down on the table, when I cut this edge, my saw is set up right, I'll have an edge that's parallel and perpendicular to my reference face. Here's where we're left. We've got 2 parallel edges, 1 good face, 1 bad face, nothing on the ends yet. You cannot take this face back to the jointer. At the joiner, we could probably get it smooth and flat, but what we don't know is, would this face be parallel to this face? The tool for that is a planer. When this goes through a planer, it's going to automatically come out the back side, uniform in thickness, with both faces perfectly parallel. Could we go to a planer first? So in other words, could we skip the face joining step and start right at the planer? And the answer typically is no, because there are pressure rollers in a planer. So this had that little bit of twist in it. The pressure rollers would take the twist out. The face would become smooth, but the twist would pop back in when it comes out the back side of the planer. So there's a marriage between the jointer, the table saw, and the planer in order to get this board to come out what we would call 6 square. So next step, I would take this to my planer, send it through until it's at the right thickness. That guarantees parallelism. Then I can come back to my table saw or a miter saw, cross-cut an end. That's now a reference end, which is perfectly square to the other surfaces. Flip it, cut it to its finished length with another square end, and you'll end up with a board that is 6 square, perfect in every direction.
As a hand tool worker, I rely a lot on my slow-speed grinder to help me hone blades and get a sharp edge on my hand planes and my chisels. So I'm going to show you a couple of things that you should do to your slow-speed grinder to keep it in really good condition and keep your wheels true and cutting well. I've got two tools right in front of me here that are pretty common. I've got a coarse grit diamond truing stone, and I have modified that with this block of wood which acts as a fence or a tool rest against the grinding fence to create a nice true wheel. Because just like when turning a bowl on a lathe that's really wobbly, you need a nice firm rest to true that bowl up and make it perfectly round. And the same is true for a grinding wheel. As the seasons change and humidity and heat and cold act on that grinding wheel, it changes its shape. And as you wear it down with your grinding, you're going to want to true that wheel back up and make it square to your fence. So, simple jig. My tool here has a 1/2 inch diameter shank, so I drilled a hole through a block of white oak or whatever hardwood you have around. Drill a hole that matches the diameter of the shank. Make 2 bandsaw kerf cuts right down the length into the center of the hole, and then I have a 1/4 inch carriage bolt that goes through, locks into the wood with the carriage head, and a wing nut on the other side to lock that tight in place. So let's go over to the grinding wheel and I'll show you how I use this. The tool, like I said, rests right on the rest that I have for my grinder. My grinder is unplugged. I'm going to spin that and just very lightly get that tool to touch the wheel. So it just barely kisses the wheel, just like that. Check it one more time. Okay, it backed off a little bit. Give it a really nice light tap. Check it again. There it goes. See how it hits on part of the wheel and not on others? It's because the wheel is out of round. So plug the machine back in. Safety, wear a dust mask. This will abrade off aluminum oxide and the binder, and that stuff is not good in your lungs. Whenever you're grinding, it's a good idea to wear a face mask. Metal dust and aluminum oxide are not good. So here we go. It takes just a nice light touch. You're going to want to drag the tool moving the tool across the rest just until all of that material is cleaned off. There you go. Should be a really nice light cut. Now vice versa, this tool here is a little bit finer of a diamond than the roughing tool here. And this tool is not used to true the wheel, it's only used to dress the wheel and make a nicer, lighter cut for when you're grinding your steel. So I'll turn the machine back on, put my mask back on, and just dress the wheel lightly with this tool. So that's the difference between those tools. This tool is just for making a nice, smooth surface on your wheel. This tool is for doing heavier shaping of the wheel. So I may not need to use this tool every time I go to the grinder, but I will dress my stone every time. When you're grinding a chisel, if you hear a lot of chatter in the wheel, then you know it's time to use this tool. Between both of these tools, you're going to have great results with your slow-speed grinder.
This tool chest has all my hand tools in it, and in all honesty, my hand tools don't get used a lot, and that concerns me because maybe they're sitting in here and stuff is happening, like surface rust is forming on them, and I'm not aware of it. Just ambient humidity, and around here where I live, the humidity can get as high easily as 90-95% in the summertime. That ambient humidity settling on the stuff is enough to start to cause rust, and I don't want that to happen. So here's the answer if you have a similar problem where you are with your tools. There are products like this available, and this is saving all my tools from getting rusty. It's crazy cool, very, very simple. When I put this in the tool chest, it gives off particles that put a coating on my tools. So right now, this marking knife has got a coating on here from that product. I can't feel it. I can't smell it. I don't know if I can taste it. I ain't going to try. But what it's doing is it's coating the metal so that it can't possibly rust. There's a shelf life to these things. So this particular one is got a 2-year shelf life. That's what the numbers here on the side mean. The 6 indicates that 6 feet in any direction, it's protecting my tool. So it's actually bigger than what I need for this tool chest. With a 2-year shelf life, for that to be tucked in there like that, that is a very, very inexpensive insurance policy for me to have to make sure that all of this stuff is going to stay rust-free. We've sourced that particular block for you on a PDF, on the DVD, and I would strongly recommend that if you have any humidity problems at all where you are, you add one of those to your tool chest. If you do, make sure that the emissions coming off of that can get to all of the tools. So in other words, if I had a big stack of drawers, and I've got a tool chest that's like this, there's a fixed shelf in the middle, I drilled holes in that fixed shelf so that the stuff coming off of that block can get to all the tools inside there. The air has to be able to freely flow up and down. Now the shelf life is affected a little bit by how frequently you're going to open the box. Like I said, for me, I don't get in here too often, so I'm probably good for 2 years. If it's a tool chest you're opening all the time, your shelf life might be just a little bit less. You can't really tell when they're used up, so your best bet is to just preemptively replace it. That's why there's a place on the side to write the date. It's a great addition for any tool chest or toolbox that you have, and a really inexpensive insurance policy that's going to help you protect the investment you have in your tools. If you're going to use plywood in your shop like this, in all likelihood, you're going to run into an occasion where you have to band the plywood because you don't want those edges to show. Now, a couple ways you can go about this. One of the ways that I like the best is a banding that's put in with a V-groove like this. So looking at that edge from this direction, doesn't that look like just one big sheet of oak? But when we come and look at the end, look at how that banding has been V'd into the plywood itself. A couple of things are cool about this. One is that V increases the surface area, so we have a really good glue bond between the edge band and the plywood. The V-groove makes it real easy to install because once we have glue in there and we seat the banding in, it can only go one way. In other words, a lot of times when you put banding on, it's slipping and sliding all over the place, and the worst thing that can happen there is you end up with a spot where the banding didn't actually cover the edge of the plywood. Can't happen with this. So it's a couple-step setup here on the table saw, but I'm going to walk you through it, and you're going to see, once you do it once or twice, it's pretty easy, and I bet you're going to be adding this to your arsenal of plywood work in no time at all. I've got my table saw unplugged because there are a bunch of setups we're going to do right here at the saw blade. The saw blade itself is set at 25 degrees. That's an important number for you to remember. I've got a sacrificial fence ready. You'll see that get used in a second. I've got my edge banding material planed, so it's exactly the same thickness as the plywood. Step one, after you have the angle set on the blade, is to get the middle of the thickness of our sheet stock and solid wood here. So I'm using this adjustable square, and I'm going to make a mark, leave it set. Ooh, I got lucky on the first try there. Then what I'm looking for as I flip this over is for the end of that blade to be in exactly the same spot. So when I'm on the pencil mark there and on the pencil mark there, that tells me that this is set to exactly the center of my material. That gets transferred over here to the sacrificial fence. So the bottom line is this mark is the center of the thickness of my material. Now the fence goes on. And here's what I'm looking for now. The very top of the cutting circle that's defined by the blade has to be just a little bit below that pencil line. So the pencil line is there. That tooth is just under it. That one's just a little high there. Pretty close right there. So I'm going to lock that height in. Now I've got this scallop that's taken out of the center of my sacrificial fence. This is the same fence I use when I'm doing rabbits and dados on the table saw. What I want to do is get that scallop right over the blade, because a little bit of the blade has to be buried in the face of the fence. So I'm sighting down through it like this, and what I'm looking for is that the teeth here are just a small part of an inch inside the plane of the fence there. All right, now we're ready to cut our edge band material. What's going to happen is I'm going to feed it just like this, flip it just like this. I'm looking for a couple things. When you start on the second pass, so I've already taken an angle off the bottom, as you start the second pass and the material gets out here, if you can see a gap between the edge of the material and the face of the fence, you need to stop, shut off the saw, then remove the piece. Because what's happening there is you're taking too much off the edge. And what will happen toward the end of the cut is that's going to collapse in. The other thing to be aware of is that we're producing tiny parts that are between the blade and the fence, and they might come zinging out this side, so make sure that you're not in the line of cut. What we're really trying to do is get a perfect or near perfect V on the end of this thing, and this first test cut in this piece will tell us if it's right or not, then we'll be able to do the real deal. I'm going to plug my saw in and show you what this cut looks like. So what we're after is that when you make cut number 2, this point needs to be against the face of that fence. So if you're taking too much off, the cut's going to be back here someplace, and with the back of the material still against the fence, the front's no longer in contact, and as soon as you finish the cut, it collapses in on the blade. If it's too far away from the cut, it's not going to complete, and you won't have a perfect V out here. So this one, the way that looks just like that looks really good. It's a V, and it's in the center of my material. So that banding piece, that test cut, is just right. So I'm going to go ahead and cut my stock for my real edge banding out of this piece. Now, if you're making a lot of edge banding, you're going to take this edge against the fence, then this edge against the fence, do that to all your banding pieces so you're getting 2 for your money out of every piece of solid. Really important here, don't change the angle on the blade. What we do need to change is bring the fence to the other side, and that's going to give us the setup that we want for the plywood. I flip-flopped everything over. Now, that scallop that's taken out of here is going to slide right over the top of my blade. Now, here's what I'm after. Let me leave the fence out of the way for a second so it's a little easier to show you. Saw's unplugged. What I need is for the left side of this tooth to be on my right side of this corner. So when the fence is correctly positioned, it's going to look something like that. What I'm trying to do is leave a perfect knife edge where that corner's at the bottom, flip it, that corner's at the bottom. That's going to create that internal V. I'm going to raise the height of the blade just a little bit. It's okay if they slightly overcut inside here and overlap. In fact, that's going to make it easier to put the banding in. The really critical thing is that if the fence is too far to your right, that corner is going to go away. If it's too far to the left, you're going to leave a flat spot there. We can fix that by moving the fence, but if you take too much off, you can't put it back on. So when I do my first setup on this, I err on the side of being conservative, and I'm going to set it so that I don't think I'm taking quite enough off. I'm pretty confident I'm going to leave a flat spot. And then I can just sneak my fence over a little bit at a time. This is a piece of scrap, same thickness as my real plywood, but it's a piece of scrap. So I can just keep sneaking the fence over a little bit at a time until I get it just right. But let's make this test cut, see how it looks, and go on from there. I got to plug my saw in, and we'll be good to go. All right, let's see what we've got. There's my detent. But look at how there's a flat there and a flat there. So that's good, because that means we didn't take enough wood off yet. So the fence has got to move over just a little bit. Do the whole thing again. What's going to tell you that you took too much off on the pass is that when I make one cut and flip it over, when I flip it, that top edge is not going to be in contact with the face of the fence anymore because it's already been cut short. So the flat tells you not enough off. Missing the fence altogether here is telling you took too much off. Now it's getting to where feeling it is easier than looking at it. Oh, that's a nice knife edge on there now. I can feel it's nice and sharp. But when I made my second cut, I was still in contact with the fence, so we're all good. So now we can do the real deal. Put away the scrap stuff, get out the real stuff, make our finished cut. Now we've got a V, and we've got a V on our banding that's going to drop right into that. Now, when I glue this together, it would be crazy to glue this big wide piece into there. So next step, before I assemble this, I'm going to rip this down to a narrower width, then have a look at gluing this all together. Now to get everything put together, glue and a glue brush to spread the glue out, get that inside the V, drop in your banding, a little bit of clamp pressure, it's going to close that right up against the bottom of your cut. So clamp that all the way down its length. Let that glue dry, and you're going to have something that looks like this. So this piece, obviously, I banded previously. In order to get it to look like this end, where it starts to look like one continuous piece of oak, what we want to do now is rip this down so that we have just a little bit of banding sticking past that plywood edge. Boy, now with just a little bit of light sanding, that edge banding is going to become just about completely invisible, but maintain a great bond into the plywood. So a couple steps of the process, but I really like the effective way this bands plywood so that you can't see that inner core. Laying out your shop, especially if you're a relatively new woodworker, can be difficult. But I've got an answer that's going to make this a little bit easier for you. And what it is all about working in work triangles. So that's what I've got established here. Now, we scrunched stuff together a little bit so we could fit it in the frame of the video camera so you could see what I'm talking about. But this is a work triangle. I've got a table saw, a bench, and a joiner. Now, the premise is these are three items that commonly work together in my shop. Here on the workbench, I set my coffee. I set piles of wood. The wood comes to the jointer, and I joint one edge. From the joiner, I commonly come to the table saw, and I rip to width. That ripped edge comes back to the jointer, where that ripped edge gets cleaned up, and then I'm piling my wood back on the bench and drinking more coffee. So this creates a work triangle for these three tools. Now, within your shop, you probably have more than three tools. We did these three because they're very common. Most woodworkers have them. But what you're going to find is that then you have an overlap that you create, and this is where you get some efficiency going in your shop. The workbench sits here. Now, maybe another work triangle would include the workbench, the jointer, and a planer, because I pile up wood, I face joint it, I take it to the planer, and I plane it to thickness, then I probably bring it back to my bench. So that'd be another one. Another one would be workbench, bandsaw, maybe a spindle sander and or a drum sander. So I've got those three tools positioned so that they're working together. So for a lot of this, the bench is kind of a place to work and a place to pile stuff is going to be the kind of pivot point on those triangles. And everything else is going to depend on what tools you commonly use. So we can throw in the router table, scroll saw, lathe, whatever else you're working with. But the key to this, to make your work go efficiently, is to try to set your tools up like we have here so that they literally create a triangle, and that's going to make it much more efficient for you to get your woodworking done in your shop. Well, you have got to admit that was a lot of information. Not only a lot of woodworking, but even a new language with those French cleats. So I hope you're able to use all of these woodworking tips in your shop, take advantage of what I showed you and what Adam showed you. Lots of great stuff happened here. Have fun and happy woodworking.
Wow, that was a lot of fun. We hope you're anxious to get into your own shop and try a few of these techniques on your projects. And you'll discover more woodworking techniques, skills, and shop tips in upcoming editions of the complete woodworking video collection. See you next time. And don't forget to check us out online at www.wwgoa.com for even more insight and information from the experts at the Woodworkers Guild of America.